What is the question? Come again. Differential of a coefficient in the context of
ये पूरा पढ़ लीजिए सर, इसका पूरा एक ही
so basically your x axis of a is a variable that is independent, and the y axis depends on x axis. So, the dependent variable is y, whereas the independent variable is x, and ordinate and abscissa you can see the definition, that is the place where a particular plot cuts the x axis or the y axis. Ordinate is the y axis and abscissa, and the slope is the derivative of a graph at a given point. So, it is basically so slope is defined as dy dx at a given point x. What else is the question? The moment of inertia is defined as it is a mass times the distance square from some axis of rotation, and this is in principle a tensor, and as I said it is a second rank tensor. The rank has a definition which I do not want to go into. You can check that in any classical mechanics or any mathematical physics book. But here it means that it is a 3 by 3 matrix. If you and these 3 by 3 comes because of the 3 directions that are involved there. Okay. Can I have the AC? I to the power minus half, what is in context with? What are the questions?
No more questions.
Any more questions? So rank of a matrix, yes. Anything else? So moment of inertia can depend upon your coordinates, and for if you are talking about spherical polar coordinates, then it will depend upon all your r, theta and phi, and as such there is nothing called a polar moment of inertia unless you write down moment of inertia in polar spherical polar coordinates. No, the potential, so this is Suman Bandyopadhyay. So, this we calculate the potential in order to calculate the force, and the force is the derivative of the potential, F equal to minus grad V. So, you take a Lennard-Jones potential or any kind of potential, and then you use that potential to calculate the force, and from the force you calculate using the Newton's law of equation, you calculate these positions and velocities and acceleration, etc., or rather the position, the force is proportional to the acceleration, and then you integrate it twice in order to get the position as a function of time, and this is what is done by the Verlet or the leapfrog or Beeman's algorithm, one of those things that we have discussed. So, the force is needed, and the potential precisely serves that purpose of having that force coming to picture, and that force would be used in order to calculate the acceleration and so on. Yes, square root of no, I mean I square equal to minus 1, not yeah, square of I, if you mean if you meant that. So, I square equal to minus 1. Yes, Himanshu, that is correct. I is the imaginary this thing. So, square of I is minus 1. Yes. Yes, any further question? I think Suman's question is answered. Please respond if you have understood what I said. So, potential is the interaction term. So, when you write down a potential, it means that is the interaction between either two particles or a particle and a bath, or between two bodies and so on. And one actually writes down say molecular potential, or one writes down atomic potential, or whichever system you are dealing with, whatever is the relevant interaction there, that is written in terms of a potential. So, V of R mostly we have taken it as a Lennard-Jones, and from the Lennard-Jones potential we can calculate the force, and the force have been used, the force has been used in order to calculate the velocities and the accelerations and the positions as well. Yes. Can I type some?
But I need to talk.
You need to type.
So,
Say that Suman and this other fellow Himanshu, if is it clear?
who's going
Thank you. Anything else? Yes, that is correct, Suman. That once you do it, so once the force has been obtained from the potential that is relevant for your problem, and then you do a double integration, because the force is, as I told, proportional to the acceleration, and then you integrate it twice in order to get the position as a function of time, and those were given by this MD formula. These are Verlet formula, and again the force at that position does not need to be calculated. Then you evolve the x as a function of t, from t to t plus delta t plus 2 delta t, 3 delta t and so on, and then you build up the entire trajectory, thinking that so the assumption is that the force is not changing, as the time as a function of time. So, force is constant and it is going to be constant throughout the trajectory of the particle. Okay. If that is something that you are looking for. So, the force corresponding force at that position is does not have to be calculated, it is not needed to be calculated explicitly. Yes, no. I is equal to root over minus 1. Is that what you mean? It is difficult. Let me write it.
Just a minute.
This is the definition of I. So, any complex number call it Z is a superposition of two numbers, I mean both x and y are real, but this I is the purely imaginary number. So, so this is called as a complex number which has a real part and an imaginary part, and the meaning of this is that you have a real axis x and you have an imaginary axis y. So, a point in this is represented by z which has a coordinate x y, okay. And this I that you see has a value root over of minus 1. If that is what you meant, it is fine. And to respond to Suman's question, so there are very few situations in which force is taken as dependent on time explicitly. The time dependence actually gets into the position and velocities, etc. If you have an explicitly time dependent force, then there are other things that are going to be coming in. Of course, there are situations in which the force is also a function of time. Here we are not talking. If you see that if the Lennard-Jones potential, it depends upon the distance. So, your question is in Lennard-Jones potential, if distance comes from attractive to repulsive zone, then the force will be changed. No. See, this is as a function of r, that f is not a function of t. So, as you bring those two particles close, then they are repulsively interacting, and as you get them far enough, then there is a weaker interaction. So, given your situation that you form a system in which the particles are randomly placed. So, between two particles which are close to each other, the repulsive force will take over, and for particles to be very far off, there will be attractive interaction between them. Okay. But for though that is the situation, that is going to remain same at all times and it never changes. Okay. So, do not make a mistake of treating the distance and the time in the same footing. The distance between the particles is what the force depends on or the interaction potential depends on, but that whatever that dependency is, that is going to remain same at all times. Any other question? Um, Code is basically I probably told you during the class, that's by a student of mine who has already graduated and have gone away from IIT Guwahati. If there is anything, any small program you want to on worldlet algorithm, etc., I can see, I can check with her and get back to you. Okay. So, this has been done in collaboration with her when she was doing a PhD, but she has graduated and gone away from here. I will try to get code if there is, but as you know, has been told that the code is simple, you have to simply evolve it from the choice of the, the knowledge of the velocities and so on, and the previous position, and then there is this algorithm has to be followed. Basically the formula has to be coded in order to take it forward, but there could be more complicacies in the program. So, I will see if there is a basic code that could be made available to you, but I cannot tell you for sure now. Right, anything else? Anything else? No, you are right. Yes, of course. I'll see if because these proteins are long chain polymers. So, the codes will be very complicated because of the interaction involved between the chains and so on, between the links. So, I will see that if there is a basic code that could be made available to you. Yes, we will try that. But you can write your own code. I mean, if you are familiar with C or C++ or Python, for example, these are not too difficult to write. And but anyway, I will try. Suman, which place, university, institute are you from? Any other question from anyone? Okay, thank you. So, are you a teacher there? Are you a teacher in college? All right, okay. Yes, I mean, I'll try for sure to have a basic code made available to you. MD is a fairly, um, strong technique in order to find the trajectory of a certain system. The only thing is that you need to know the form of the force, or at least you have to have an idea of the form of the force. That is the only requirement for this. And then of course, the rest of the things are by one of the algorithms. Really does not make too much of a difference which algorithm you take, but velocity worlet is one of the common algorithms for doing these kind of simulations. These are all classical calculations. I mean, your force, etc. So, these are really molecular systems at macro scales, at large scales. Anyone else who are watching? Anyone else have any question? So, since there are not many questions coming after that, we are thinking of winding up in another 5 minutes. If there are no questions, we will wind up in a few minutes from now. Please ask if you have questions. Okay, thank you so much. You mean to say that to teach things, further things in this using these techniques, that can be done, but you see that these are classes. So, you need to take into account that there are large number of people who would just want to know one simulation technique. That is why I have given equal stress on both MC and MD. And have done at least one problem each with each one of them. And well, it will be a pleasure in the future to go further with this. If this course is offered again, I will definitely think about it of doing some more examples with MC and MD techniques. Thank you for that. That's right. Last chance to ask more questions. Suman, yes, I do interact after the course by email. I'll stay in touch if you can write to me. Imanshu, force is a vector, so it's always important to split it up into horizontal and vertical components. So what I mean by horizontal is that horizontal has two directions x and y, and vertical is just one z. So since force is a vector, it's usually written in terms of the horizontal and the vertical components. Any specific question to that? Yes, okay. Let me have this board. So you have force, that's a vector. So this is split into, suppose you have a planar force which is a function of x and y only. Then you can split it up into f cos theta in the x direction and f sin theta in the y direction. Okay. And this is how it is split in terms of angles. So, there is a particle of mass m which is at a position, say, so this is that this is r and this is r cap vector. So, so this is your x axis and this is your y axis. So, this is acted upon by a force in an arbitrary direction, and so this force is known as, so this is your f x and this is your f y, and this is the angle theta. So, then the force is written. So, let us say the force is acting in this direction. So, then this force is written split into two components, which are the horizontal and the vertical component, but in a two dimensional sense. Okay. So, this horizontal is f x and the vertical is f y, and the force is written, force as a vector is written in terms of this, where theta is the angle between the force and the x axis. So, I just redrew the axis here, where this y, this is the direction of y axis and this is the x axis, which is drawn at this point. At this point where the force is, where the mass is located or the force is acting. Anyone else has a question? Thank you, Himanshu. Others? Anyone else? Thank you, Himanshu. Yeah, I think the later part, at least more than 2 weeks we have spent in talking about the simulation techniques. So, that part is quite important, and most of the other numerical methods course that exist in the platform, they only talk about numerical methods and mostly using a computer. What I have stressed on in this course is that not to use a computer, and still on pen and paper these methods should be clear. And even as complicated as the simulations, sometimes I have tried using it on pen and paper. And you can do that, of course, you will have to use your calculator and so on. So, it is pen, paper and calculator, frankly. That is what all you need in order to understand the idea behind this course. There are other, as you can probably see, that there are other numerical methods course, but none of them talk about these simulation techniques. And the other thing that I have tried to do, at least, that is the both problems related to science and engineering have been covered to some extent, and in which there are problems from chemical engineering, from civil engineering, from mechanical engineering, as well as there are physics, chemistry. These are the things that we have tried to, and of course, there are many examples which are purely of mathematical interest. This is by and large the upshot of the course. All right. So, if there are no more questions, we will wind up in 2 minutes. Thank you, Suman. It's really something that I wanted to do, that for numerical methods always one does not have to resort to computer, and this is what I have pretty much tried to do, that you can get the idea of numerical methods just by using pen, paper and just a calculator. The numericals, Himanshu, are you a teacher again? You could reply that. But the students should be encouraged to do numericals because it is in their best interest, because if you do not encourage doing numericals in the class, then the students do not learn anything. This is by and large the the thing that is followed in IITs, that there are no questions such as write short notes on or write explanations of and things like that. It is always problem oriented, and at most of the times it is numerical problems. There are of course small derivations to large derivations that are asked in class or in exams, but numericals are the best way for students to learn and understand the concepts behind topics that are there. So, that way the students should be always told to give numericals, and we have, as a part of our teaching, every week there is a tutorial class in which we help the students in solving numerical problems, and at times even some of the problems which are not numerical, but they are based on concepts, getting expressions and getting dependencies of various parameters and so on. So, those are also done. So, it is the students should be always encouraged, and because you can say that all these national level exams such as JEE, JAM, GATE, CSIR, etc., they are all problem based, they are all numerical based, they are all based on the concepts which are needed in order to solve them. So, it is very important that the the students do these numericals, take these numericals seriously and so on. Okay. So, I see 4 of them watching, but only 2 have asked questions. I believe, thank you Himanshu. I believe the others also have some questions, but however, it is almost towards the end. But if you have a quick question, you can ask. Thank you, Suman. Thank you very much. So, thank you very much to all of you who have watched and who have attended the course. I really enjoyed teaching this course for the last so many months, and I hope you have enjoyed that as well. Take it as a as a learning platform of doing numerical methods, and I have tried my best to have a correct blend of engineering and science problems. I do not know how much I have succeeded in doing that, which of course, you can give the best feedback for this. But however, this is my understanding that video is on audio. All right. But you can tell me about that, and if you need to stay in touch with me beyond the course, after the course gets over, you are most welcome to do so. My email address, etc., you will get it there. It is my first name. If you go to the IITG website, and I belong to physics department, I am a professor of physics. So, you can definitely find my name there. So, you can ask me questions, and you can tell me if you have any problems, or rather if you have any queries regarding this. There are many other simulation techniques which we of course cannot be done so easily in a course, but however, I will keep my efforts on in order to also include them in future versions of these numerical methods and the simulation technique course. So, all the very best for your exams. I am sure many of you, or rather all of you, have submitted all these assignments, and the exam is scheduled probably next month. The exam is scheduled next month, and very best wishes to all of you for that, and happy Diwali too. Thank you.